Okay, thank you. Now I just wanted to show you the design output from your. We have done materials, we define sections, we model, we put boundary conditions, we load the structure, then we run analysis. Actually, analysis, you should know that we have various analysis options. We can use grillage. We can use finite element method, which is predominant for Midas. Can do those of frame analysis. You can also use inference line. By the way, one day I will demonstrate for you the inference line and we will look at some graphical, very interesting, though maybe may not be more accurate than use of finite and the frame analysis. So those are some of the options that we have. So having done the analysis and you have seen the bending moment, the shear force, the axial loads, now you move into design. So here, this is now where the design is. You come to this design, and it's the reinforced concrete. I told you you will do your design code. You do design code, you put it here, and then you label all that. You come to first safety factor that if you want to modify or you update by code. You see it as updated by code. You say okay, then you go to modify concrete. Normally this concrete, all this material must be in line. You check that they're all in input, so that you modify all that. Then you come down to serviceability limit parameters. Now you see this exposure clash depending on the concrete cover. You go to the code of practices and then you make sure you pick what is applicable depending on the soil and water quality cover requirement. Now if this being if you look at it, is more of quasi. If you also want frequent, if you know that the characteristic load has got both frequent characteristic, quasi permanent, and these two, make sure you highlight that. The quasi permanent deflection control has been given here, or this user. So characteristic deflection control is given, deflection application factor. If you have another, you can check in the code and you do that. So that has to be defined. Then you come to submit this one. These are all then generated from the software because it was automatic. So it has now given you have 3 for quasi permanent, you have 4 for frequent, and you have that for that. Now in this design I need to note that we don't have plates. These girders you see are basically typical. These are concrete girders. Yeah, this is a girder. This is a girder. So these are the one they combine them to give you the whole thing. So it's not a plate. If there was a plate, it would also give. So here, that's how the whole thing is. So you need to appreciate that. So this is all frames. The scenarios where if I want now to do local effect analysis, I will check the effect of wheels on this transversely. So I can now do the plate and the deck slab as plate, and then the girders as frame. There you are able to do that. Yeah, so after you have done all these combinations, then you come to, we have beams. There is a beam here. You define this beam properly, and then after defining this beam, you also specify reinforcement, the same beam, but beam for checking. You come this pier cap, you see reinforcement, and then this is the diaphragm, that's the diaphragm, and that is in I, the middle, and the Z, the sectional. So you define them all here. And the issue of stirrups, you put in everything. After you have done all this, you now go and do, even for column, you come here, then pier is here, then you define the cover, and then the stirrup, then now you go to pier column for checking. This is also here. You see we have put reinforcement bars are here. So it's asking for two layers of reinforcement. So that need to be checked. So basically that is what you have. Then for having done that, now one thing also I need to take note, Midas does not design each section here for unreinforced concrete. Unreinforced concrete design, Midas doesn't design this one. It does it on when it is post pre-stress system, where you have post tension and reinforcement, then you design it. But when it's reinforced concrete, I've tried, I realized doesn't. So you have to convert this into it's like a T. This has to be a rectangle. You have seen from here that the section that is designed beam section, it is on a rectangle. There's no provision for different shapes. So if Midas could try to do these different shapes here, the T, the other I section would be okay. It will be very helpful. So here you can see it's only the rectangle section. So these are some of the limitations we have in using Midas. So the Midas gurus will be able to do that. Okay, so now I can now go and view you can go and view your beam checking. So when I click, it's running. It takes a bit of time to run the design. Basically, it's now making reference to all the code clause, and then yeah, you will see the output, and you know that it is not just an instant. Even the software will have to do some random access stuff to get you what is good. So what we are generating is the design of the pier cap and the diaphragm. Those are the rectangle sections that we have. But also the good thing is for the pier itself, that shape, it also designed. So we shall have a look at the octagonal shape. Is also designed. That's the good thing. But the tapering one, no. Midas does not design tapering sections. These are some of the things I need to. So for tapering, what you do is you just convert the tapering section into a series of reducing rectangular sections for you to be able to get good result out of it. So you spend some time and convert the tapering section in series of rectangular members. So you're able to get something much reasonable and reliable. Okay. So this has taken much of my time. Oh, so this is what you get out of that. So we can demonstrate this. We look at the graphics. So you can actually see that this is your peer cap. My bending moment capacity has gone through the positive moment, then shear capacity has also passed, and then the ease of the stirrup spacing are given. Um, Okay, then that is for the pier cup. Then for the for the diaphragms are here. They also passed. This one also passed. So the two diaphragms have passed. Now how do I, if I wanted to look at the detail, let me see, I will go to the member and maybe I try and I want to see if I can get one demonstration. So this is what you guys are able, this is what you guys are able to generate. So this is your, this is this is our diaphragm. So you can see the kind of results that you get out. It does for you all the checks. You remember all these section definitions in your Kung and Evans and mostly books, textbooks for design, how to determine all this. They're all here for you. Checking the crack width, they're all here. You can see permanent. So it gives you a very, very good analytical report that you can base on. This is different from, so this is how you can get your graphics, and then you can do for the rest actually. Even serviceability limit state is here. Serviceability limit state I think appears member. It's the same actually. It's here down so somewhere here. Check stress limit. These are all crack limit. These are all here. So I think this one demonstrate the, so I can quickly look for the peer. So if I look at the output of the peer, instead of running, it will take time and time may not be enough. I can quickly check here, whereby I can look for where is my peer support. I need to look for the peer. Peer cup and diaphragm. Now I need peer support. Where is my peer support? Is here. So this is how what to get out of peer. This is double layer, and these are the layer details are given here. This is the check they do for you. PM interaction diagram, the shear force resistance checks. You should be able to appreciate all this. So this is what you can do. You can use actually Midas, do for you all the design, do all the output. You just give it to your CAD engineers to do the detailing. So ladies and gentlemen, this marks the end of demonstration on modeling, loading, analysis and design of reinforced concrete precast eye girder bridge. Next I will demonstrate the pile design and abutment design. So thank you so much for being a good listener. Now wait your feedback. I've shared my knowledge. What is your take and what do you think? Thank you. Have a good day. Have a blessed day. Let me do now some work. Very well, but this is a good lesson because now I'm happy that I'm mentoring future public servant, future private sector led team. So let me be a happy gentleman now. Enjoy tomorrow with you guys. Thank you so much. Have a blessed day. Bye bye.